All right, let us try out another question here. So you can see over here they say that our x is normally distributed. So our x over here is normally distributed with a mean of 30 and standard deviation of 5. So that's 5 squared. Now you're looking first the question you're looking for the first question you're looking for the probability that x is less than 39. So we have probability that z, we change it to z, is less than 39 minus 30 over 5. So what we have over here, probability that z is less than, when you place a calculator over here, you get your 1.8, which is very good because it's just exactly less than. So we have 1.8 on this side over here, and looking for the less than, looking for this area over here. That means this area here is going to be exactly the phi of what? The phi of 1.8. So you go on our tables and you find the phi of 1.8, which is going to be 0.9641 from the tables. I'm not showing the tables over here, so we shall go. I'll make one video for the tables so you see how we use the tables. All right, because I cannot move back and forth. All right. Now, the main reason for this video is this part B and part C, getting the inverse, getting the inverse normal. So let us go to part B. All right, now for this part B over here, they are saying that there is a value D such that the probability that x is less than D is equal to that probability. One of the things we need to know, we need to check first, if this is the mean for x, say we know the mean is what? It's 30. Where does D lie? Is it on the left or on the right? But you can see over here that what they have over here is, just erase this. Okay, so you can see that the probability of the less than is very small. That means we expect that value of D is small compared to what? Compared to 0.5. It is less than. That means we expect that D to be over here because the probability is less than 0.5. So this area over here is the area which is 0.1151. All right, now all we need to find over here first, before we think about finding the D, we need to find the Z value that gives us this area. So our focus now will be on the Z value that leaves an area of 0.1151, and we can reflect this in the positive side. We can reflect it in the positive side and have this D value reflected over here as this area here as the 0.1151. That means we're looking for D, but D, if this D is negative, when you reflect on this side here, the D will be positive. So if this is negative, that's the D. I'm not changing it, so I'll change this one to be what? To be a negative D. So in order for me to get the inverse normal, the Z value, I'm looking for the Z value that will give me this area over here to be 1 minus this area, 1 minus 0.11115. And when I have 1 minus 0.1151, I will have 0.8849. So I'm looking for the Z value that gives me this area over here. That means I'm looking for the inverse Z of 0.88449. Now, if this probability over here, which is left over here, I'll explain this one more time. If this area over here was like 10%, 20%, or 5%, 2.5%, 1%, we can use what we call the percentage points. But this area here is just 0.1151. So we are going to use we are going to go into the tables of the Z value and find the inverse of this value over here. Let us try to go to the Z tables here. Need to do, I'm looking for this z values over here. These are the probabilities. I'm looking for this probability. These are the probabilities. To find the probability of 0.8849 and let's see what's the z value. So this column I'm looking at, this column over here is a column that has 0.88, 0.8. Lucky enough, we have our value exactly over here, 0.889. That means that the z value that gives you that probability is going to be 1.2 over here. That z value that gives that probability, that the inverse normal or the inverse z value. So from the table, our z value over here is 1.2. That means this value D will have a z value of 1.2 when you standardize it. But how do you standardize it? Remember our formula for standardizing? The formula for standardizing, we say it was z equals to x minus what? Minus mu over the standard deviation. That means our z, which is 1.2, is equal to the x value, which is D we are looking for, minus the mu, which is 30 over the standard deviation of 5. But remember, I said D is on this side, but we just transferred into this side in order for us to read the probability. That means this one is supposed to be a negative. So we can make D the subject over here and try to calculate the value of D. We shall find out here that D is 24. I want to answer part C without removing any of the calculation we have done. If you see over here, I'll change the color. If you see part C, you're seeing over here, the probability is exactly the same. That means they have the same z value, but it's less than and this is greater than. It means that if this D is 24, the number, the value of E they're talking about is the value on this side over here, which is supposed to be like the negative D, but of course it's not negative, but in the Z terms it's going to be negative. So if this value is 24, this value is only 6 below the mean. That means this value over here will also be 6 above the mean. That means over here the E is going to be 36. Remember, I put over here negative D because I was explaining it if this was a Z value, right? But now I'm explaining it if this is already 30. The mean is 30. So you go down by 6 and then up by 6. How do I know that? Because here the probability is probability of less than, which is over here, which we have got over here. And here the probability of the greater than, which is over here. But all these probabilities are the same. They have the same probability, 0.115, and this is 0.1151. So it is a reflection of the other. And we know that we have found the first one, 24, because you're going down by 6. That means the next one, E, will be up by what? Up by 6. So E is 36 without any calculation, any further calculation. All right. For part E is also something that we can do quite quickly, because we know the value of D. Even if you don't know the value of D, we can D and E, we can answer this because these guys have given you this area over here. We know that this area over here is 0.1151, and this area over here is 0.11151. So we are looking for the middle area. How do you find the middle area? It's just 1 minus 2 multiplied by 0.1151, just the middle area. That's what you're looking for. So that means this probability over here is 1 minus, when you double this, what do you get when you double this one over here? So when you double, you get 0.2302, and then you find the answer over here is 0.76998. That's a probability. Because this one, you know already that this area is the same as this area over here. Even if they're not the same, you could just add them. Now we are fine for just the area in the middle over here.